Hello everybody. Today we're gonna talk about trigonometry in architecture. Introduction. Trigonometry from ancient Greek trigonon, triangle, and metron, measure is a branch of mathematics concerned with relationships between angles and ratios of length. The field emerged in the Hellenistic world during the 3rd century AD from applications of geometry to astronomical studies. The Greeks focused on the calculation of chords, while mathematicians in India create the earliest known table of values for trigonometric ratios, also called trigonometric functions. Throughout history, trigonometry has been applied in areas such as geodesy, surveying, architecture, celestial mechanics, and navigations.
Hello, my name is Muhammad Khairul Azman. Today I will talk about real-life application trigonometry in architecture. Trigonometry plays a crucial role in architecture as it helps architects and engineers design and construct buildings and structure with precision. Here are some ways in which trigonometry is applied in architecture. Calculating angles and measurements. Trigonometry functions like sine, cosine, and tangent are used to calculate angles and distance between various points on a structure. This is essential for ensuring that components fit together accurately. Roof design. Trigonometry is used to calculate the angle of a roof. This helps determine the slope required for proper drainage, as well as for aesthetic purpose. We need to find this middle. We need to use the middle tangent, which is we will use the calculator to find out the answer. So the answer will be that's the answer from the papa. This is the answer of the angle. So the angle is
So example 2, the diagram shows a stair is placed 10 meters away from the base of the building and make an angle which is 60 degrees with the ground. So how to calculate this is that the adjacent for this building, this building, the building to the triangle is 10 meters, and the opposite, which is h, from the building. So now we have to find the now we have to find the height, which is the opposite, that is h, from the building. So first, you already know that our angle, which is 60 degrees, just by looking at here, 60. And now we are using the tangent form, which is opposite over adjacent. So by subbing, which is sub into sub, subbing into A, which is 10, so our tangent will be this. Or you can replace the O with the letter H, because since you're finding H, so it depends on your best choice now, which is you want to use opposite, which is O, or H, which is we want to find the words right now. Now, since we know that we're using a tangent, this 60 is placed inside the tangent here. So it become tan 60 plus O over 10. Now, easiest part is that we can change this by using a calculator. That we get 1.732 or square root 3. Yes, square root 3. You can either use 1.732 or square root 3. We're going to use square root 3 since it's a bit easier. We use square root 3. Then H over 10. We have to move the 10 over here, which is times. Since this is a division, anything that goes from the left is either a times or a division, will be the opposite. So right now we have division. If we move to the left, we get multiplication, which is times. So square root 3 times 10. Your H will be 17.3 meter. Therefore, that the height of the building is 17.3.
In conclusion, trigonometry is very important in the field of architecture. This is because we can solve many problems that architect has to face in their career, like what we can see in example 1 and example 2. With the help of trigonometry, we are able to witness some of the most iconic building structures like Burj Al Khalifa Hotel, Pisa Tower, Petronas Tower, Taj Mahal, St. Paul Cathedral, London and Empire State Building, etc. Without trigonometry, we will not able to witness these masterpieces.